I'm going to review how to use the dimensional analysis technique to complete unit conversions. So the answer of the unit conversion is not our goal. The process and technique of dimensional analysis is really what we want to focus on. So you'll need to refer to my instructional video on how to set up dimensional analysis to get the beginning lesson of this. This is going to be me working out examples, assuming that you already know the basics of the technique. So in this first example, we're asked to convert from minutes to weeks. So let's come up with a plan of how we can go from minutes to weeks. So the first thing that I would think about I personally do not know how many minutes are in a week, but I do know how many minutes are in an hour, and I do know how many hours are in a day, and I do know how many days are in a week. So I think this would be a good flow chart that we can use to set up the calculation. So the first thing I'll do is write down the number I'm given, 7,900 minutes, and I'm going to use dimensional analysis fraction bars for equalities to get those units to cancel out. So I'm going to get minutes to cancel out, that is my old unit, and I'm going to convert to the new unit, hours, on the top. So again, the old units are always going to be canceling out on the bottom, and the new unit will always be on the top. I need another dimensional analysis fraction bar to work my way down the next portion of the flow chart. So let's get the old unit of hours to cancel out. So I forgot to cancel here. So minutes is canceled now, hours has canceled out. We're going to go to the new unit, days. So the new unit always goes in the top. Still not to the end of the flow chart yet, so let's keep going. I'm going to get days to cancel out by placing that on the bottom. So the top and bottom will now cancel with days, and my new unit, weeks, will be on the top. All right, so I've got to the end of the flow chart. What I'm going to do is I'm going to plug in an equality in each of these dimensional analysis fraction bars. For example, there are 60 minutes in 1 hour. So notice how I read that, 60 minutes. So I put the 60 next to the minutes, and the 1 goes next to the hours. There are 24 hours in 1 day. So the 24 goes next to the hours, and the 1 goes next to the days. There are 7 days in 1 week. So the 7 goes next to the days, and the 1 goes next to the weeks. So let's go ahead and get those to cancel out. So we're going to take the 7,900 to, sorry, I got sidetracked. So let's go ahead and divide these. Remember, if anything is in the denominator, it's going to be division. So in my calculator, I'm going to take 7,900. I notice that the 60 is on the bottom, so I'm going to hit divide by 60. Now, depending on what mode of calculation you're using, some calculators will let you type things out in a strand without hitting equals, but our school division is using Desmos right now, and you can actually not type things as a strand there. So to be safe, you could go ahead and press the equals after that division by 60. Let's go to the next one. The 24 is in the denominator, so we're going to hit divide by 24 equals. Let's move on to the next segment. So the 7 is in the denominator, so we'll need to divide by 7 equals. So the answer I got is a number that's less than 1. That means it's less than 1 week, and for this activity we're going to be rounding to 2 decimal places. So I'm going to get 0.78 weeks. All right. So that's my final answer. Remember, for dimensional analysis, you're always going to see this diagonal pattern of our units. Notice how the minutes matches the minutes, the hours matches the hours, the days matches the days, and then the only unit that doesn't get canceled out is the one I'm solving for. So always look for that diagonal pattern. Let's go to the next problem. So in the next problem, we're given 25.9 years to hours. Well, I definitely don't know how many hours are in a year. So let's think of a flow chart of how I can get this to work. So I'm going to go from years. Now there's a couple of things that I could do. I could go from years to months. I know how many months are in a year. I could also go from months to days because I know generally how many days are in a month. And then I don't know, know how many hours are in a day, so I could do that. Other techniques that you could use that would be equally wonderful are you could go from years to days to hours. You could go from years to weeks to days to hours. I'm going to use this one just because I'm going to use this one here in purple just because it's the one that I wrote down initially. So I'm going to write down the number that I'm given, 25.9 years, and I'm going to use dimensional analysis to get that old unit to cancel out. Now I'm going to go to the next unit in my flowchart, months. But I don't want to stay in months. I'm going to need to go further down my flow chart. So let's add another dimensional analysis section, and I'm going to get months to cancel out. All right, and now I can go to my new unit on top, which will be days. But I don't want to stop here because I need to get all the way into hours. So let's add another dimensional analysis bar. So I'm going to get days to cancel. All right, and now I can go to hours. So I know that I'm at the end because hours is a unit that I'm solving for, and every unit with this diagonal pattern canceled out. Now I'm going to plug in equalities representing how each of these units relate to each other. So first off, we're going to think about how many months are in a year. All right, so for months, I'm going to say that there are 12 months in 1 year. So notice the order that I wrote that. The 12 is going to go on the top next to the months, and the 1 will go next to the year. For the next part, we have days and months. All right, so in general, it's accepted that there are 30 days in 1 month. So notice I wrote the 30 next to days and the 1 next to months. All right, so let's also say I'm going to talk about days and hours. Well, there are 24 hours in 1 day. So because of that, I'm going to put the 24 next to the hours and the 1 next to days. So notice that everything is in the numerator. So this is going to be multiplication. Depending on how you're going to type this into your calculator, pretty much every single calculator out there will allow you to type this into a strand. It's when you get into division that Desmos that our school uses sometimes gets a little confused. So I'm going to type this in one strand in my calculator. So I'm going to do 25.9 times 12 times 30, because it's in the numerator, times 24, because it's in the numerator. And I'm going to get an enormous number, 223,776, and my unit will be hours. All right, so that's an incredible number of hours that will be in 25 years. All right, so if you solve this problem using one of the other techniques, you're going to get a slightly different answer. So for example, if you chose to go from years to weeks to days to hours, you're going to get a slightly different answer. Again, there's many other flowcharts that you can use to help you set up this dimensional analysis problem. You're going to get approximately the same. So it doesn't matter whether you use this flowchart idea that I have here in purple or one of these in green, you're going to get something that's approximately close to 223,000. All right, let's go to the next problem. In this particular one, it says Susie measured out 7,962 milliliters of water. All right, so because of that, we're going to notice that we're starting with the unit milliliters. She says, how many liters of water is in this? So I'm asked to go from milliliters to liters. Now, I don't know if I can do that directly, so we're going to select to consult this chart of equalities. So notice how milliliters and liters, let's see, there it is. Look, I can go directly between milliliters and liters. So this is going to be a very short one-step problem. So to complete the problem, I'm going to write down the number that I'm given, 7,962 milliliters, and I can go directly from milliliters to liters. So to do that, I'm going to get my units to cancel out with the old unit, milliliters, on the bottom, and the new unit in my chart, liters, will go on the top. Now notice in this equality, the 1,000 is written next to the milliliters, and the 1 is written next to the liters. So I'm going to do that here as well. The 1,000 will be written next to the milliliters, and the 1 will be written next to the liters. So I'm going to divide 7,962 by 1,000, and I get 7.962 liters. Okay. Now let's look at another situation where I'll need to use this equality chart. So on this particular problem, notice how it says a block of iron weighs 5.9 kilograms. What would be its mass in milligrams? So as I look here, I'm going to notice that here is milligrams and here is kilograms. I, at least on this equalities list, don't have a direct relationship between milligrams and kilograms. And I'm going to assume that this is the only information I have. Yes, you can definitely Google and look up how many milligrams are in a kilogram. But I do not have that information right here. So I'm going to have to set this up in a flowchart. I'm going to go from kilograms, and the next unit I can go to would be grams. All right. And then from grams, I can go to milligrams. All right, so let's go ahead and use that flowchart to help me with my dimensional analysis. So I'm going to start with 5.9 kilograms, and I'm going to get the kilograms to cancel out, and I'm going to go to grams. So the old unit kilograms has canceled, and the next unit, my flowchart, grams is on top. I'm going to need another dimensional analysis bar, so I'm going to need to get grams to cancel, and I'm going to go to the new unit in my flowchart, milligrams. Now I'm going to use the relationships in my equalities list to help me figure out how to set this up. So I'm going to have the 1,000 grams equals 1 kilogram. So the 1,000 is going to go next to the grams, and the 1 is going to go next to the kilograms. Let's take a look at the next part. I have 1 gram equals 1,000 milligrams. So the 1,000 milligrams is going to go on the top, and then the 1 will go next to the grams on the bottom. So again, just to review, the 1 goes next to the grams, and the 1,000 goes next to the milligrams, like we have set up here. So when I get ready to type this into my calculator, notice how all of my values are in the numerator, which is multiplication. So you can type this in your calculator or complete it in your head. We're going to do 5.9 times 1,000 times 1,000. And when you do that, you're going to get a ginormous number. So let's see. You're going to get, you can add some commas in to help you make it a little more understandable, 5,900,000 milligrams. Or your calculator might give it to you in scientific notation. So if they gave it to you in scientific notation, the decimal would be moved 1, 2, excuse me, I didn't actually mean to make that mark. 1, 2, 3, 4, 5, 6. So to the positive 6th power. Some calculators might give that result like this, E6. That E would mean the exact same thing as this, times 10 to the, and then 6 would be the exponent. So this is calculator talk. We're not allowed to write information in this way. So make sure that you translate this information into something that is actually real, such as one of these. So I won't accept this, but this guy or scientific notation is fantastic.